Hey, what's up there, YouTube? It's Brian House here for Housework, and today, real briefly, we are going to go over some of the design revisions that have been happening on the new design for the 2x72 grinder. This is a grinder that I've been conceptualizing now for the last couple of weeks. The last video, and I'll put a card up so you can watch that, it's kind of the introduction and sort of the concept, just really thrown together, the concept of what this thing is going to actually be like. And I had some goals for this thing, one being it should be easy to build and that the materials would be readily available for pretty much everybody. If you've got a steel mill near you, or even a place that sells steel, you should be able to find all the pieces to this. And you can also build it with rudimentary tools, meaning you could do it with a welder and a cutoff wheel if necessary. I mean, you probably would really have a hard time cutting the plate, but I think you'd be able to do it if you were really motivated. Let's just say that. Otherwise, we'll come up with a design that's just tube steel, that's based off of this design, and that way it's even more accessible to everyone all around the world. That said, let's dive right into the actual technicalities of what I've done. I've done a lot of refinement on this design, and the first thing you'll probably notice is the hinges are different. This is a challenge. When you're designing hinges to rotate anything, even if it's on one axis, there's a lot of math and geometry that is associated with it that if you don't have a program like SketchUp, it would be really tough to conceptualize this. I can't even imagine trying to do this on paper. So anybody that's actually designed one just by doing mock-ups, I give you a lot of respect. So as you can see, the hinges are much bigger. I listened to your comments. A few people said, those hinges look awful tiny, and yeah, they really were. That was a design that didn't make a lot of sense. Now in this case, they go all the way up to pretty much the top and bottom of that tube. They're 4.5 inches tall by about 3 inches wide. So they're not huge, but I do think that they can handle the weight of the top grinder head, for lack of a better term. Now in SketchUp, there's this really cool functionality where you can actually build in an axis to something and see it mechanically function. So I went ahead and learned how to do that, and now I can kind of play around with the way it turns and moves and all that. And you can see here we got clearance for everything. I can't remember who made the comment about moving the axle over into the center of the stanchions and then notching the side. I apologize, I can't remember who it was that said that, but thank you very much. That helped a lot. Tried this in about 3 different ways before I went back, reread that comment, and went, light bulb went off, and boom, there I was. It came to me in the form of a lot of trial and error. So you can see clearance here is pretty tight. This is designed to be mechanically sound, so that when it's in either the horizontal or the vertical position, there are other pieces of metal supporting the grinder head. All right, let me just show you how this functions without the grinder attachment there to obscure the view. Now you can see I do have a little bit left to round over on the stanchions there, and I figure that most likely will not be a hard angle, that notch that's inside of that stanchion will be rounded over. Let's see if we get a better shot of that. So yeah. So I'm thinking here this will be a radius, which makes a lot more sense than having a hard angle there, but I just designed it this way, and I figured in production we can actually go back and kind of refine this thing. One of the big reasons I love SketchUp is that I'm doing all of this with a computer and not trying to do this in real life. If I was trying to do this in real life, I think I would have gotten so frustrated that I probably would have quit. It's not a simple task to design something like this. So anyone out there who's an engineer, you guys are awesome. So anyhow, you can see how this fits in and works, and everything is super tight. In theory, that hinge system should function really well. Now, I have a question for you guys. I eventually will be CNC cutting these on a plasma table. My thought is, because the plate that holds up the motor itself is going to be 3/8 of an inch thick, or 0.387 thick, would it behoove me to just cut all of these pieces out of that same sheet? Meaning the hinges would be the same thickness. Right now I've got them designed, they're 1/4 of an inch thick, or 0.25, and I think that's adequate, but you know, I can't imagine a reason why thicker wouldn't be better in this situation. Those hinges, all of the weight of the grinder itself is riding on this little situation that we've got going on here. All the weight is being pushed down onto essentially these holes, these notches and these stanchions, and on those hinges themselves. So I'm thinking more surface area is better. And you guys tell me if I'm, you know, I can't, not only that, the cost of doing it isn't that much more. So if you look at the difference in cost of a 1/4 inch plate, which somewhere I've got my invoice from Tampa Bay Steel. Okay, so for a 24 by 24 inch 1/4 inch plate, mild steel, I paid $31 each for those. And I just ordered 4 3/8 inch thick, the same size of this, and it was $130, I think. So 4 pieces at $32.99. So there's a price difference literally of $1 and change on these. So I can go from 1/4 inch to 3/8 inch thick for less than $1 for the whole sheet. That's a no-brainer, I think. You guys tell me. I don't see any clearance issues in here. I think that this is, to me, it looks like if I were to add another 1/8 of an inch onto there, let's see, 3/8 of an inch, yeah, that would be another 1/8 of an inch to the width of these hinges. Should work out just fine. Okay, so let's go over some of the additional changes that I've made since the last video. One of the big changes was that I swapped the platen arm and that bottom receiver. So the platen arm was originally in the bottom receiver, and I swapped them. And when I did that, it raises the height of the platen. I was a little bit concerned about that. I wasn't really sure if, the height while you're working, would it be okay or not. And that's kind of yet to be determined, although I measured my old grinder and it seems to match up just fine. So I think we're going to be okay there. The other thing I did was I put in place an actual 7-inch drive wheel to kind of see what the geometry looks like here. One of my concerns is when that is mounted in here, and we're going to do a faceplate mount, you can see here the bolt holes are right on the outside of that plate, and you're going to have not a ton of clearance between the drive wheel and those nuts, or the head of the bolts that are actually holding the motor in place. And I thought about maybe some heavy duty machine screws. Now the threading on that motor is 3/8 16 course thread. So I don't know if our options, what our options are as far as the mounting bolts and the screws that we're going to be able to use for this. But that is a concern. I do think that it will be okay. As you can see with SketchUp, when you design, say, like the belt, it'll kind of tell you, like, this belt is on one axis. And you can see pretty clearly that we have decent clearance for pretty much the entire belt. Let me just pull that wheel back into the mix here. You can see the belt, it's close. So I don't know, we'll see. But I did move the wheel just off the plate about 1/8 of an inch to, I think, 3/16 of an inch maybe, just to give us a little bit more clearance. Now, a few of you did mention the spring was the wrong kind of spring. That was just something I downloaded from the library online because I was being lazy, so I really didn't want to, nor did I know how to make a spring from just geometry inside of SketchUp. So I went ahead and downloaded something. I have since gone out and found a better spring to represent what we're going to do there. Now, a couple people did mention that instead of using a spring system like this, we could go with a hydraulic, and that hydraulic would be just underneath. It would span basically between the pillar, the tensioning pillar, and the tracking wheel. And I sort of like that idea, although I think in terms of longevity when I design stuff like this, in 40 years, is a hydraulic still going to be good? Probably not. It'll, be expensive to replace, and if you can find the right tension and all that. If we find a spring, we're kind of guaranteed that spring is going to last a long time. So I think I'm going to stick with the spring idea. I really like that, and I think it's going to work. That leads us into the tracking portion here. I have yet to really fully design the tracking, although I bought the tracking wheel and the hinge from Origin Blade Maker. They sell a whole wheel attached to an axle, attached to a hinge that you essentially weld to your tracking arm. So I went ahead and just bought that as a whole piece, and I got it on eBay. I'll put links down in the description so you can go out and find that on eBay. I just think that that's going to make it easier for me, although I'm not really fully sure how it's going to work. My other tracking arm on the old one was pretty simple. It was not a complicated build, so it's the same concept, right? The wheel has to move on a specific axis to allow the belt to move back and forth. So I think it's a pretty straightforward situation. I don't think we're going to have too much trouble with tracking. I kind of dig the hinge idea because it gives you more flexibility on the downswing. I felt like in my old build, the downswing, the bracket, the way I made it, and this could be that I just did it wrong, but the bracket would run into the pillar, the tensioning pillar, and it didn't have anywhere else to go. So you kind of ran out of downward travel on the tracking arm. So with this, I feel like I can get a whole bunch more movement. I think I'll get a much better fit. One of the things I did think a lot about was adding the same kind of hinge that I added to the tilting mechanism on the frame to this guy right here. This is the top platen attachment. Again, this is totally optional. You don't have to build this, or you may not even want it, but a few people have asked me, what are you gonna do with that? Now, I built one for my old grinder. Really like it, and here's what I use it for. I built a soft platen attachment for the forward-facing platen, and the top platen is actually a hard platen, so I can go back and forth, back and forth. And in this build, I'm going to leave the hard platen in the forward face, and then I'm going to put the soft platen on the top. And what that'll allow me to do is work on my geometry a little bit differently without having to change attachments. It's a luxury item, and I feel like but it's really cool. I mean, I put a Scotch-Brite belt on that thing, and again, I'm building this grinder because, and Jay Keaton said this to me right after I got punched in the apron with a piece of steel, was that belt turning towards you is not real safe. And he's right, and I knew it. I just did it anyway. But that belt turning towards you is not real safe. I had no options though, because I wanted it to reverse it, but the tracking sucked. So this is where we're at. A whole new project just because of that. However, I really do love the idea of building this thing. I think it's going to be super cool. And that articulating mechanism would be really simple to build. And SketchUp allows you to kind of mock it up so you can kind of see how that would work. I got an email from the gent who is cutting all of my pieces out on a CNC. And it looks like he's going to be able to get those to me next week, which I'm super stoked about. It's hard for me to allow somebody else to kind of come in and do this for me, but I really don't think I have the capability or the capacity to cut those hinges. I could probably get away with the plate. The hinges themselves, I don't think I could do as good of a job. Well, I know I can't do as good of a job as a CNC, but I don't really have the time to do it. So someone reached out to me and said, hey, I've got a CNC plasma, I've got the plate steel, send me the file and I'll cut them for you and mail them to you. And the reason why that's attractive is obviously I can get this prototype built. We're just having a slight issue with when I send him the file, the conversion on his end is just slightly bigger. So if the hinges measure out at 5x3 on my end, they're measuring out like 5.13 on his end and 3.3 on his end, something like that. Anyway, it's just getting, it's so precise because for the motor plate, that cutout there for the plate itself, if that's not right, none of this will fit. So you really don't have a lot of room for error. Also, the mounting bolt holes for that motor, it's pretty important that they're in the right spot. So anyway, we're working on that and trying to figure that out. Hopefully by next week I'll have it and we'll be able to put together a prototype of this really soon. Again, my aim for even approaching a project like this is the desire to be able to give people an understanding that if they want a tool, they can build it themselves, and we can design a tool that works just as well as, let's say, a $2,000 grinder that you could build for maybe, say, $500. I like that concept. I like the idea. I also like the idea that my kids, when they watch this channel, they see Dad producing something out of nothing and having an idea that is, comes to fruition. I love that concept. So I'd like my kids to see the world in a different way, and the only way I'm going to be able to do that is if I do something different. If I contribute to society by doing something like this. If one person builds this grinder after this series is over and sends me a video of it, it will be a great day for me. I love the idea that we can come together, collaborate, produce something, design something, trial and error. Is it going to be perfect right out of the gate? Probably not. Are we going to make a ton of mistakes? Yes. Will it be a lot of fun? Yes. Will we learn something? Yes, we will learn something. And I love that concept. I love that we're able to share freely this information. The concepts that we're putting into place here, from understanding just what an X, Y, and Z axis is, what steel is, how to work it, how to cut it, how to weld it, how to form it, how to shape it, how to make it work, how to make a motor turn, how to wire up that motor, how to control a VFD. All of those things would not be in my skill set if I didn't have YouTube. So I love that we're able to share this together, and I love that I can contribute back. My goal for this build has always been to also build a viable business around it. So through design and production of these pieces and parts, I want to be able to have them available on my website eventually for purchase. So if you're watching this video and it's a year later, go to my website, housework.us, check in there and see if I've got the parts available, because if I do, that would mean that all you would have to supply is the tube steel. I'll probably supply the tube steel cutoffs as well, so you can buy a la carte. You can buy all the pieces to this grinder, one piece at a time. You can buy a whole kit. You can buy everything through me, and that would be another great way to support my channel. Anyhow, guys, I appreciate you watching. Thank you so much. As always, there are links down in the description that will show you anything I have available right here in my workshop in my studio. That is a free way to support my channel. If you go on there, it's all broken down into different categories. You can actually see all the different personal safety products I use, tools I use, knife making supplies, all the way down to 2x72 belts. It's all categorized right in there. And if you buy something through Amazon, through those links, I get a small commission and it helps support my channel. Now, if you want to take the support to the next level, I do have a Patreon page now, and for as little as $1 a month, you can support my channel by contributing to this. That's $12 a year if you do the math, but I am producing some things in here that are really expensive. My production equipment is expensive, my time, all of those things. So any help is greatly appreciated. I do read and respond to all comments. So if you have any questions or comments or suggestions, please leave them down in the comment section and I'll respond to them as they come through, as long as they're productive. As always, guys, I appreciate you. Thank you so much for watching. My name is Brian House, and this has been Housework.